And in order to make sure that this event is truly cloud native, CNCF sent their representative here to make a keynote, an official keynote done by CNCF developer advocate. With that, I want to welcome Luc Perkins, developer advocate from CNCF.
I occasionally give talks. I go to a lot of conferences. I try to establish good relationships with people in our various constituent projects under the CNCF. It's a really fun, cool job, and that's me. So in this particular talk, I was asked to give a kind of high-level overview of cloud native, the cloud native paradigm, the CNCF, and so on and so forth. I feel like nowadays we've reached a point in the life cycle of the paradigm that I don't feel it's really necessary to give the sort of bare bones introduction to containers and Kubernetes and things like that. I feel like if you're at Cloud Native Day in the year 2019, you probably have a pretty good intuitive gut sense of what it all means. So I'm going to do something a little bit different and give a high-level overview in the sense of what I think some of the very interesting developments are that are going on, and to provide a general sense of where I think things currently stand within this broad sort of universe of projects and tools, and to also point to what I see as some continued challenges and some areas that I think are still in need of some work and some diplomacy and some collective action. So this is my kind of my sort of one-off State of the Union address, so to speak, for where we are. So I'm going to start by pointing to what I take to be some very interesting and promising developments happening in the CNCF and the cloud native landscape. One of them, I think, is the rise in the importance of policy making and policy enforcement. So I'm going to talk a little bit about Open Policy Agent, which is to me a very interesting project in the CNCF and also something of a rising star. I'm going to talk a little bit about what I see as convergence in a very and what I take to be a very important domain in the microservices paradigm. I'm going to say a little bit about the emergence of the service mesh interface, which is something that came about at the last KubeCon as well, and discuss some of the implications behind that. I'm going to give describe what I take to be some more general currents within Cloud Native as well. Like I said before, I'm going to point to some continuing challenges. And in case you're wondering why I'm giving this particular overview, well, like I said before, I think it's, I want to use this opportunity to gesture towards some areas in our field that are in need of some special help. So, promising development number one, Open Policy Agent and the policy-driven stack. Who here is familiar with OPA or Open Policy Agent? Is there anyone from Styra who's here? The company Styra? Just curious. So in case you're wondering what OPA is, so OPA is a declarative policy framework. And to me, one of the most interesting things about OPA is that there are 4 different ways in which you can use it. So you can use it as a CLI tool to evaluate policies in certain environments, like if you're just experimenting on your own in a development environment, or in an environment like a CI/CD kind of integration. You can use it as a sidecar process in a Kubernetes pod. So if you have some process or service that needs policy judgments rendered very quickly, they can delegate that to an open sidecar. You can also use it as a simple Go library. It's Opa's written in Go, and I think that this is a very interesting thing where you can essentially have in process policy judgments And you can also use it as a REST API. So in cases where you need to have, potentially some centralized policy judgment hub within a larger architecture, you can simply delegate policy judgments to an open process that's running and available to lots and lots of different processes. So a very cool thing, and something that I think is relatively unique in the open source landscape, is that Open Policy Agent has its own policy language called Rego. Rego is a little bit weird. I haven't quite. It's kind of like the Go templating language. I feel like I'm on the verge of making a breakthrough and like really understanding how it works. The syntax is a little bit odd and a little bit unintuitive. I haven't mastered it yet personally, but I do think it's really cool that they have developed a domain-specific language for working with policies. Another thing that I love about OPA is that it's so extremely flexible in terms of what you can do with it. So the way that OPA works is you essentially feed it JSON and a policy written in Rego, and it gives you some kind of JSON output back. And what this means is that there's virtually no limit to the number of things that OPA can fruitfully interact with. So if you want to use it in conjunction with the Kubernetes API to render judgments on the fly about what should be allowed, what containers you should allow to be deployed, so on and so forth, you can do that. You can use it in conjunction with Docker and other container runtimes. You can use it in a kind of deployment framework with tools like Terraform. And I do believe that there's an official Terraform connector. You can use it in a service mesh context to make all kinds of judgments about authorization policy, what forms of traffic are allowed to what kinds of services, what sort of users are authorized to do, to set what kinds of policies and limits and so on and so forth. And to me, I think the very interesting, the very fruitful thing at the heart of OPA is that it enables you in either in a Kubernetes environment or any other super complex domain to establish, like, I guess the analogy would be a zero trust model in security. Inside of a Rego policy, so one of the things that I always do when I write Rego is at the very top I say default allow equals false. And what that essentially means in OPA land is that you can set up a system whereby nothing is allowed until you explicitly say that it should be allowed. So imagine that you apply OPA at the CI level, and I actually just published a blog post on the OPA blog today about using OPA in a CI setting. So there's a shameless plug for me and my work. But what that essentially means is that, imagine that, okay, I'm talking too fast. Deep breath. So in a CI setting, so imagine that nothing is allowed to be built. No artifact, no container, no static binary is allowed to be built until a certain set of policies is reached or is satisfied. And the example that I give in the blog post today is imagine something like a dependency blacklist. Like imagine if you want to prevent, the event stream library in NPM or leftpad or something like that from ever entering your code base. OPA is a way that you can do that. So you can apply OPA at the CI level, at the deployment level, at the Kubernetes level, the service mesh level, essentially anything essentially anything in any software architecture that produces JSON can be used in conjunction with OPA. And so the implication behind OPA from where I stand is that there's been, in the last couple of years, there's been an explosion of activity in the cloud native space, all kinds of new tools, all kinds of super duper powerful, shiny, bright objects that do amazing, powerful things. But one of the consequences of that is that the implications for things like security, for example, continue to be very unclear. So what OPA provides is a kind of constraining framework for for dealing with this Cambrian explosion of things. So imagine if you have all these great tools, you have this amazing scheduler in Kubernetes, you have all this powerful service mesh stuff, and so on and so forth, and you want to actually use it in a heavily policy-controlled environment. OPA provides a super powerful lever for you to do so. So that's positive, I think positive development number one. So number two is some convergence going on in the telemetry space. So telemetry is essentially shorthand for information emitted by services. So nowadays that encompasses distributed tracing, metrics, and logging. So OpenTelemetry is a collaborative project that was just accepted into the CNCF a few weeks ago in anticipation of the last KubeCon in Barcelona. And what OpenTelemetry is it's a joining forces of the Open Tracing project, which has been in the CNCF for a couple years, and the Open Census project from Google. I have Open Tracing in bold because it's a CNCF project. And what OpenTelemetry, rather, is aspiring to do is to create a single set of language-specific libraries and collection mechanisms for three things: for distributed tracing, for metrics, and eventually for logging. I think logging is something that's going to come along a little bit later. But the first two are currently in motion. Another really interesting project, which at the moment I think is a little bit, has become a little bit stalled, perhaps because of some politics. We know how specifications go. But that's the Open Metrics project, which is also under the CNCF as a sandbox project. So what Open Metrics is, so if any of you have used Prometheus, and I'm sure that a lot of you have, Open Metrics is an effort to harden the, maybe it's not the right word, to crystallize the Prometheus exposition format, which I think is emerging as a default standard into a specification decided upon and governed over by a committee. So in case you haven't seen the Prometheus exposition format before, I think it's a very interesting way to do things, and personally I think it's an improvement on some older formats like StatsD and others, because it gives you this sort of key value interface for interacting with metrics and selecting them and exposing them. The potential implication of Open Metrics, which I find to be very promising as well, is that you can potentially, it has a potential to furnish total compatibility across different metrics providers. So if your services, as long as your services are exposing Open Metrics formatted data, then you can potentially export that to any number of metrics providers. And as we know that there's currently a very robust metrics provider ecosystem. Okay, gotta slow down again. And so the implication here is that I do think that there's an implicit unity in this field that is becoming a reality. That's perhaps a little bit controversial because tracing and metrics and logging, it could be I guess it's controversial to say that these are simply one unified object domain. But I think on a gut level, it feels inherently right to me that a project is coming along and bringing those domains together, and at least making an effort to provide a way to expose all three of these things via one single set of libraries and interfaces. Okay, the third thing is service mesh interface, and this one, was anybody at KubeCon and saw the talks on service mesh interface? So service mesh is a super interesting domain because, well, for good reasons and bad reasons. The good reason is that service mesh is an incredibly powerful thing, and I think it offers it has a lot to offer for all kinds of microservice architectures, for all kinds of large deployments, and so on and so forth. But this is also a domain that's been very heavy on politics from the very beginning. So what Service Mesh Interface is doing is that it's bringing together what I take to be some of the major players in the service mesh space. So Istio is currently on board, which means that Google and IBM are on board. Linkerd, which is a CNCF project, is also participating in the Service Mesh Interface specification project. Console Connect from HashiCorp is on board as well. So what the Service Mesh Interface is trying to do is to establish a common set of Kubernetes resources that you can use regardless of who the actual regardless of the actual implementation that's being used. So imagine if you can be a developer or an ops person writing Kubernetes configurations and trying to configure traffic rules and policies and authorization access control in a service mesh. Imagine being able to do that without having to care which service mesh is actually operating under the hood. So without having to worry which control plane is being used, or even which service mesh data plane is being used. Seems pretty interesting to me. At the moment, the Service Mesh Interface, or SMI, is targeting three of the main domains in traffic management. So one of them is access control, and it's operating under kind of, I guess, analogous to OPA's default allow equals false. It's operating under a denial by default assumption. It's also going to incorporate rules for splitting traffic. So that's so the ability to, for example, route 30% of traffic to service D and 70% of traffic to service E, and to change that split and that dynamic over time. It's also defining a common interface for exposing service mesh metrics. So imagine if at some point you would be able to use kubectl to interact with the service mesh interface with no knowledge of who the actual service mesh provider or implementation is, and to gather or potentially even to run multiple different service mesh providers in the same Kubernetes cluster. So the implication from where I sit is that it's a much needed injection of diplomacy and boredom into a highly acrimonious and volatile domain. Maybe. It really remains to be seen. It seems like a fruitful project to me. It makes me hopeful that the major players have decided to put aside their differences and sit down at the same table. But given what we know from controversy surrounding Istio and Google and open source strategy, it's still a little bit early to tell just how positive this development is going to be. It could be something that in a couple months from now has completely disappeared from the scene, or it could be the start of something really, really fruitful and powerful. So we shall see. Sorry. Okay. Well, I guess I'll wrap it up really quick. So what I see in general in the cloud-native CNCF space right now is I think that specifications, which are kind of annoying, are kind of the politics surrounding specifications can be super frustrating from time to time. But I think that we're seeing an expansion of them into more and more domains of the Kubernetes cloud-native stack. And as far as I can tell, this is a good thing. It's going to constrain innovation in ways that will ultimately be beneficial to developers and ops people and SREs alike. Analogously, I think another thing that's going on is that we're seeing a standardization of some of the basic plumbing in the cloud-native space. So, in the sense that we can make more and more assumptions about the systems that we're running against. or running on top of rather. So Chris Aniszczyk from the CNCF is fond of saying that Kubernetes is the POSIX layer for the cloud, and I think that that's pretty much correct. And what we're seeing now with things like OPA and Open Telemetry and the service mesh interface is that the kind of the padding surrounding services is also becoming heavily standardized in ways that could potentially be very fruitful. We're also seeing some slow expansion into some very intriguing new domains. We're seeing projects like KubeEdge pushing Kubernetes and cloud native into edge computing in ways that are very exciting. We're seeing things like network service mesh, which is actually an L2, L3 networking stack that runs in Kubernetes versus the L4 through L7 Kubernetes networking stack. I mean, imagine doing networking in Kubernetes in ways that has nothing to do with CNI or the higher levels of the stack. Pretty wild stuff. Continuing challenges, I'll just go through these very quickly. The databases continue to be a very difficult thing to standardize on due to, I mean, honestly, due to the fact that there are so many very good cloud databases. There are some interfaces in common that enable cross-cloud portability, but this, I think, is going to, for the foreseeable future, is going to be a pretty big barrier to making cloud native truly cross-cloud, truly cloud agnostic. I am going to skip the other thing. So, yeah, thank you very much, Montreal.